Let's execute this code. Yes, all two cases are successful for us. And let's submit this code. Our solution is accepted and all 143 test cases are passing. And this is programmatically how we are going to calculate whether the string is a palindrome. Hello friends, today we are going to learn about two-pointer approach or sliding window method using a Leetcode problem. This problem falls under easy to moderate level complexity because here both the pointers are going to be symmetric. There are going to be other two-pointer approach where the operation on both the pointers are going to be independent of each other. It is going to be non-symmetric. Here symmetric means we are going to do same or similar operation on both the pointers, so it is going to be easy to understand, and this problem will be a good starter point for anyone who wants to learn two-pointer approach or a sliding window methodology. Let's go into the problem. Leetcode problem number 5, longest palindromic substring. Given a string S, return the longest palindromic substring in the S. So example 1, input is BABAD and the output should be BAB, because palindromic is nothing but if you read from left to right or right to left, the string should be same. So BAB is same as from left to right also, from right to left also. And in this string of 5 letters, this 3 letter is in palindrome. Or else you can additionally pass ABA, because ABA is also palindrome. Read from left to right ABA, right to left ABA, both are same. So this is also correct. And you can pass either BAB or ABA, both are acceptable answer. And for example number 2, CBBD, BB is the palindrome. There is no other palindrome, so BB should be the output here. And constraints, the length of S can be between 1 to 1000. So here we can safely assume that the length of S will not go to 0 and we don't need to worry about the corner case here. And the other constraint, S consists of only digits and English letters. As I told you, this problem falls under two-pointer approach. The other name for two-pointer approach is nothing but sliding window approach. First, let's try to understand the concept here. Taking the example 1, BABAD. Here if you see, this is the palindromic string and this is odd number of palindrome. It means there are 3 characters here. So this is the center character and these two are same. Taking the example number 2, CBBD. This is an even number palindrome, 2 characters here, and there is no middle character, only left and right. So a palindrome will fall under 2 different categories, the odd number palindrome or even number palindrome. So odd number palindrome will have a center character and there will be multiple characters around that. For example, we can say A, B, A, B, A. So this is center character and these two are same. Similarly, these two are same. But in the even number character, there is no center character. Only the left and right are going to be there. For example, we can say A, B and B, A. Here also there is no middle character. Only a gap is there. And both sides of the gap are going to be same. And this is a even number palindrome. So you have to understand the difference. Odd number of palindromes, there is going to be a middle character and left side and right side are going to be same. And in even number of palindrome, there is no center character, only a gap is there and the left side and the right side of the gap is going to be same. Let's see how to identify whether a string is a palindrome with odd number of characters programmatically. So let's remove the example 2. We will come back to the example 2 later. Let's change this one to B. So we can consider it as a 5-letter palindrome, center character same, and the left side of the characters and the right side of the characters are same. So this is a odd number palindrome. Taking this as an example, we are going to identify whether this is a odd number of palindrome or not. So this is an odd number of palindrome because by seeing it only we can say, but we have to see how we can able to find this in programmatical way. So here this is center character and left side and right side are going to be equal. So what we are going to do is, we are going to iterate every character. So we will have for loop of this particular string. We will take the first character and assign 2 pointers towards this. So left and right. So what we are going to do is, if the left and right are pointing to same character, so let's say this is yes, let's write it as this is the list yes, and we are going to do if s of a, sorry, we are going to say if s of left equal to s of right, it is going to be palindrome. So what we are going to do, we are going to take one character and assign two pointers left and right, and then we are going to compare. Then compare is if s of L equal to s of R, it is palindrome. So we can say pal str equal to s of L to R plus 1, because in Python this is a upper bound, it is not inclusive, so the R plus 1 will not be taken. We have to take from L to R, so the right number is going to be R plus 1. So from string L to R is a palindrome, we are going to store that in the palindromic string. So consider this, we are taking the first character, assigning L and then R, both are to the same character. So this check is happening, L and R are same, so we are going to assign pal str equal to s of 0 to 0 plus 1, because L is 0 and R is 0, so s of 0 to 1 is nothing but the character A. So currently we will have pal str will have A, we will write it down here, pal str is currently going to have only A. Then the for loop continues, so for loop goes here and we are going to take this character, assign left, right, we are comparing, both are same, this is same and this is also we are going to assign, we will write down, instead of A we will store B here. But now what we have to see is, we are not going to stop only with the if condition. So this is the critical two pointer manipulation here. So when these two are same, we are updating the palindrome string. Along with that, we are going to decrement L and increment R. So we have taken this particular character, assigned L and R for this one. When L and R are same, we update this palindromic string. Along with that, we are decrementing L goes here and R goes here. The pointer gets incremented. And we are going to keep doing it again and again. So it is not going to be an if condition, it is going to be a while. So as long as s of L and R are going to be same, we are updating the pal string. Along with that, we are decrementing L minus equal to 1 and R plus equal to 1. This is the important core concept here. So we take this particular character and assign this one to L, this one to R. We come and check S and R are same, so we are updated A to B, the pal string is B now, and then we are reducing L. L was initially here, now L minus 1 points to this one, this becomes L, and R was initially here and R plus 1 goes to here. So now again the while loop runs and L and R are same, so we are updating again here. Instead of it was initially B and now it is becoming A, B, A. So now the palindromic string is pointing to a bigger string than the previous one. This palindromic string will simply have pal string. Additionally, we will have a max pal string. So we'll have something as max pal, and whenever a pal string has a string which is greater than of max pal, we will update that. Initially, we will assign this to empty string. So when we assign A to pal string, we will update the max pal to A, because the logic is going to be if len of pal str greater than len of max pal equal to pal str. So when initially A was assigned to pal string, this comparison happened. This is 0. So this is 1 is greater than 0. So max pal is updated to A. A is getting updated here. When B is updated here, already A is here, the length of pal string is 1, length of max pal is 1, so this condition is false, we are not updating max pal here. But when we update ABA comes to the pal string and the length of pal string is 3 and length of max pal is 1, so this condition is true and this update happens. So instead of we having A here, this becomes ABA. Hope you understand this point. So we are going to have, this is our logic, core logic. We will start from one character and then compare whether it is same. If it is same, update the pal string and then reduce the left, increment the right, left comes here, right goes here, and then if it is still palindrome, if these two characters are same, it is still a palindrome, update the pal string. Whenever we update the pal string, we compare the length of pal string with the length of max pal. If the length of pal string is more than the max pal, update the max pal string also. So that's what happening. Going forward, we have taken B and this is the left and this is the right. Both are same. Decrement left, increment right. So left comes here and right goes here, but this left is falling off the boundary. So off the boundary, we stop. So we need to have additionally not only this check, along with that check, we need to have check of and I greater than or equal to 0 and sorry not I, left greater than or equal to 0 or less than len of s. Hope this logic makes sense. Actually we need to check the length before comparing, because or else we will get this array out of bound error we will get. So this AND operation, this boundary check should come before this check. We will modify this when we are writing the program. So this check is false, so we are going to out of that. We took B and then left and right here, updated B, then decremented left, incremented right. So left came here, right went here, both are same. Again updated AB here, updated max pal here, then decrementing left, incrementing right, left comes here, right goes here, and this left is out of the boundary and len L greater than or equal to 0 is false. Because of this condition false, this while loops comes out. So we are not going to execute the while loop again, and we will come back to the for loop which is previous, which is like the outer side of the while loop, and this time we are starting from the character A. So now this is the character currently we are going to do, and for this character assigning L, assigning R, L, R. So this boundary condition is true, S of L is S of R. So update pal string, A comes to pal string, it is becoming A. The length of pal string is only 1, length of max pal is 3. So this condition is false. We are continuing. We are going here. Then L decrements, R increments. So initially L was here, R was here, decrement L to here and increment R here. So comparing both. First of all, both boundary check is true. L is greater than or equal to 0. R is less than the length of S. And then both S of L and S of R are same. So S of L, R are same. So updating the pal string. Updating the pal string from ABA. Initially it was B. Now it is going to be BAB. Then we are checking this length which is 3 with this length which is 3. Both are same. It is not greater than. So condition false. We are not updating max pal. Update, it is staying that we are not updating here. So coming back here, again reducing L, incrementing R. So L was here, R was here, this is R, this is L, and decrementing L, L goes here and R goes here. This condition true because L is 0 now, which is greater than or equal to 0, and R is 1 minus len of S minus 1. So this condition is also true. R is less than len of S. And now this condition we are checking, S of L is same as S of A, both are character A, and this is also true, and updating pal string to S of L to R plus 1. So we are going to store this string into pal string. So pal string was initially pointing BAB. We are going to update this A, B, A, B, A. So pal string is pointing to this one now. everything else is kind of out. So this is, it is pointing out. Now comparing this length, which is going to be 5 character, and this length, which is going to be 3 character. So this condition is true. We have to update max pal. So what we are doing, updating max pal, remove this one, instead of that store A, B, A, B, A. So naturally the max palindrome string got updated here, but we didn't stop because intuitively we know that we have reached the actual max condition, but programmatically we didn't do that, right? There should be some exit condition. So we are keep continuing the loop. So both are same, we updated max pal, then still we decrement L and increment R. So initially L was here and R was here. We are decrementing L, incrementing R. This is a new R, this is a new L, and this condition false. So L is greater than or equal to 0. It is false. Same. Len L R is less than len of S. Both are false. So the while loop goes out. So while loop is not continuing anymore. Outside of the while loop, we are going to have for loop. That for loop iterates to the next character. Next character is nothing but B starting with left pointer, right pointer. It is same. Update the pal string, but this length is only 1, which is not greater than 5. So we are not updating max pal. So L is shifting, R is shifting. This becomes L and this becomes R. Still both are same. Continuing, updating this pal string to A, B, A, but we are not updating max string because this length is only 3, this length is 5. So we are not updating it here. Continuing the while loop, L is shifting, R is shifting, L comes here, R goes here, R is out of boundary. So R is greater than length of S, so that the while loop exits. So when we do an iteration with this B, we are not updating max pal. Max pal is staying with the older known value. Again, the for loop continues, going to the next character, starting with L, starting with R, and both are same. Updating pal, value is just A, length is 1, which is not updating max pal because it is not greater than max pal. So max pal stays with just ABA, and L shifts, R shifts, L comes here and R goes here. R is out of boundary. This condition goes false. So this while loop is not continuing, and we are going to the for loop. For loop also ends because we don't have any more character here. Okay, and this is a programmatically how we are going to calculate whether the string is a palindrome. If there is another 2 characters, let's say C and D here, this will stay with this one only. When we are at A, we will go here, here, but when we are at this place, this will not be updated. So even there's a substring into the given string, this max pal will store that substring. If the entire string is palindrome or not, or if the substring is palindrome, whichever is the maximum palindrome in the given string will be stored in the max pal. And this method is only for odd number of palindromic characters. Now let's see what we should do for an even number of palindromic characters. Let's take the example 2. C, B, B, D. Here same logic, I am not going to write it once again, but only difference is we have outside for loop, and that for loop we are iterating one character at a time, and then we were assigning L and R to the same character. That was the case when we are doing with odd number of palindrome. But for even number palindrome case, the gap between the character is going to be the middle point. The letter is not going to be the middle point. So always the L and R are going to be outside of the gap. So L and R are not going to be same character ever again. So what we are going to do is we will iterate every character, but I and R we are not going to assign to same character. Instead of that, we will assign L to the first character and R to the next character. Suppose if I am taking C for this iteration, I am going to assign L to C and R to B. In next iteration, if I am taking B as the character, I am going to assign L here but R here. But everything else is same. Let's try to do a walkthrough, but I'm not going to write the code here. Let's say max pal, and then we'll have pal string. So the logic is going to be same. We are going to assign L and R to additional characters, but after assignment we are going to check whether S of I and S of R are same and if they are crossing the boundary or not. If pal string is greater than max pal, it is going to be updated. Let's quickly do that. The outer for loop starts with C, and this is going to be L and this is going to be R, and both are L less than or equal to 0, R greater less than or equal to len of S, both are true, and S of 0 is S of 1, the left and right are both are same. It is not same. In this case we are not going to continue the for loop. Pal is not getting updated, so we are going to next character. Going on, selecting this character, this is L and this is R, both are inside the boundary, and S of L equal to S of R. In this case we are assigning this one to pal string, so pal string is going to be updated with BB. And initially max pal was assigned with empty character, so this one has a length of 2 and this one has a length of 0. When this is greater than, we are going to update max pal, so max pal is getting updated to BB, 2 characters, and again both are same. So this is the character we have taken, and this was the L and this was the R, and L decrements, R increments, so this becomes new L and this becomes new R. Both are under the boundary but they are not same, so pal string is not getting updated, max pal not getting updated, and we are moving on. Taking this character, this becomes L and this becomes R, so now both are under the boundary, but S of L is not equal to S of R. So while loop exits, we are going to the next character, taking D. This is going to be L and this is going to be R, and R falls outside of the boundary, so we are not continuing the while loop. Coming back to the for loop, and when the for loop ends, so whatever stored in the max pal is going to be returned, and this is how we identify the maximum palindromic string. If it is a odd number of palindrome, we have to start with one character. If it is even number of palindrome, we have to start with the Greek or 2 character in parallel. This is the difference. So we will have 2 for loops, one for loop to iterate in this method. So inside the for loop, I and J will be assigned to same character, sorry, L and R will be assigned to same character, but in the another next for loop, we are going to have L and R are going to be assigned to next characters, subsequent characters. So we will have 2 for loop to solve the problem, but as an optimized method, you can do that in the same for loop. So the for loop is going to iterate each character, and the top portion of the for loop is going to handle for odd number of palindromic string. We are going to assign L and R and then we will identify, and in the same for loop at the bottom portion, we are going to do the even number palindrome calculation. We will see the implementation in the code. While I am doing the implementation, you will understand it better. But while seeing the code, please see the explanation also side by side. Maybe you can open that code as well as explanation in 2 tabs, and for every line you can come to the correct explanation point and then correlate. So it will make the problem more understandable to you. Let's go into the implementation. As we have discussed already, we are going to have a max pal string which is initially empty. Is going to be empty. Then we will have a for loop which is going to iterate every character, but we don't need a character, we need the index, because we are going to assign the numbers to the L and R, and then we are going to increment in the numbers, decrement in the numbers. So let's have for index in range of len of S. Now inside the for loop, first let's try to identify for odd number of palindromic strings. So in the odd number of palindromic string, what we do is we take one character and then we assign both I and J to same character. So in this case we have taken index, so L equal to index and R equal to index. Both are same, and we are going to have a while loop. So while L greater than or equal to 0 and R less than len of S. The R should be less than the length of the string, so then only it can point maximum to the right character, and S of L equal to S of R. the same condition here we have discussed. As I told you, this range check should come before the value check. So that's what we are doing here. Then if it is same, what we are going to do is we are going to assign palstr s of L to R plus 1, and then we are going to increment and decrement L minus 1 and R plus 1. Before that, we have to check if pal string length is more than max pal, then we have to update that. So let's check that if len of pal str greater than len of max pal max equal to pal str, then we update. So while loop will keep flowing. In the same for loop, we are going to do the even case also. In even case, what is the only difference? We will take a character and we will assign L to that character, but R to the character plus 1. So that is the only difference. L will be index and R will be index plus 1. And everything else is going to be same. We'll just do the same while loop. We'll just copy from there and then paste it here. And that's all we have done with the code. We can simply return whatever is staying in the max pal. Let's execute this code. Yes, all two cases are successful for us. And let's submit this code. Nice, our solution is accepted and all 143 test cases are passing. And this is how we learned the two-pointer approach or a sliding window method. And as I told you, the operation is going to be symmetric. We are decrementing L and incrementing R. But there will be other complex problems where we are going to have different operations on left pointer and right pointer. Or there are cases where left and right may even cross over. And to understand those complex problems, to go to the next level of your DSL learning, please don't forget to subscribe and join the community. And thank you for watching.